Hey AP Physics students, here's some hints for T12.2, page 535, number 28. Now, as you look at this, it's a double star problem. And as you've seen, because it's a double star problem, I think you need my help on this one. If you don't, I'm really impressed. So a couple things I'll do to get you started on this one. First of all, we will involve both of these formulas. The magnification is the opposite of SI over SO, and 1 over the focal length is 1 over SO plus 1 over SI. So remember, the magnification is how much bigger or smaller the image is compared to the object. And SO is the distance from the mirror to the object. SI is the distance from the mirror to the image. And these are very useful formulas. As you look at this, on number 28, they give you a piece of information. Give you a couple of pieces of information. It's a spherical mirror, so we have a convex and a concave side. On the convex side, the magnification is plus 1/4. Okay, and that ought to make some sense because the image is always right side up or non-inverted on the convex side. And on the concave side, that's not always the case. So they give you a plus 1/4, and that's nice. However, now how do we apply this? So as you look at this, so I'll give you a couple of hints about this. We're going to use this. We know the m is 1/4. So the hint is, then you set this equal to 1/4. All right, so that's fine, except we still have a couple of unknowns, and we'll keep those for a moment. As we look at this, my suggestion is you start with the formula this way. Right? The opposite of SI over SO equals 1/4. Then what might be useful to do is to solve for SI. So use this to solve for SI. Then what I would recommend doing is plug this SI, wherever this is, in for there. As you substitute this, then you'll end up with a formula which has F in it, the focal length, and also SO in it. So that seems like it's kind of frustrating because you still have an equation with two unknowns. But recognize that then you are going to switch and look at, so it says, what is the magnification when it's on the concave side of the mirror? The object remaining the same distance away. So we recognize the SO will be the same. And what's interesting about this and very useful is the SO stays the same on this, and the focal length is the same, except now the focal length is positive. So because the focal length is positive, that allows you to solve for the magnification. So I think that's sufficient for you to solve this. Yeah, I think that's enough, and I don't want to give any more away. So come see me if you want a little extra help on this one. Good times.